Hello everyone, welcome to the discussion session on tutorial 4. On this video, we'll try to cover question 1 on the calculation of earth pressures. As you can see, on your question, you're given a cross-section of a proposed concrete retaining wall, where the unit weight of the concrete is 23 kN per meter cube. The soil is cohesionless, fully drained, with an effective friction angle of 535 degree, and the dry density of the sand is 90 kN per meter cube. Assuming no wall friction, that is Rankine, but assume a friction along the base of the wall equal to 2/3 of phi prime. We need to determine the value of the factor of safety against sliding and overturning for both of the following assumptions. Number 1, with passive earth pressure developing at toe of the wall, and number 2, without passive earth pressure developing at the toe of the wall. Finally, we need to comment on the influence of the passive earth pressure on the factor of safety. Now let us try to incorporate the parameters that we have in our figure. As you can see, you are given the value for the soil parameters, gamma equals to 19 kN per meter cube, and the friction angle, effective friction angle of the phi for the cohesionless soil is 35 degrees. There is no C or cohesion value that indicates the soil is fully cohesionless. This is the concrete retaining wall that has an upward surcharge of 50 kN per meter square at a distance of 1.5 meter from its crest. So on this figure, we can see the vertical effective stress distribution diagram for our plot. So here, this is the 5 meters that is coming from the height of the retaining wall, where 4.5 meter is above the ground surface, 0.5 meter is below the ground surface. We are having an imaginary line of 2.63 meters that is giving this triangular distribution, which we can get by dividing this surcharge with the unit weight of the underlying soil. So here, this is the parameter 50 kN per meter square that is coming as a vertical effective stress at the top surface. That with the increase in the depth goes to a value of 145 kN per meter square. We can subdivide this earth pressure distribution vertical effective stress diagram into two parts for ease of our calculation. So this is on the active side. So as you can see, the generalized formula for the vertical effective stress here is the gamma W, but as in the question we do not have any groundwater table, GWT, we can consider this one as 0. In the next step, we'll calculate the active and passive earth pressure coefficients as per the method specified. Here on our question, we're given the Rankine's method, phi prime equals to 35 degree, where the active earth pressure coefficient, KH, equals to 10 square 45 degree minus phi prime over 2. So this is the active earth pressure, vertical effective stress distribution diagram that we got from the previous slide. Now, if we draw the active earth pressure distribution diagram, we just need to multiply the effective stress at each of the depth with the KAH from our active earth pressure coefficient at each of the depth. So that will give us the active earth pressure distribution diagram. On the next step, we have a very small height of 0.5 meter where the retaining wall is inserted in the ground. We can calculate on the passive side what is the earth pressure or the vertical effective stress. So considering this one, because there is no height of the soil, considering this depth, we can consider 0 meter down to 0.5 meter. Thereby, we'll come out to 9.5 kN per meter squared at a depth of 0.5 meter. Exactly following the same equation for vertical effective stress distribution diagram. From that, calculating the kph equals to 10 square 45 degree plus 5 pi prime over 2, we can get the passive earth pressure distribution diagram. On the next step, from our literature, we know that the factor of safety sliding is FSL is the summation of the resisting forces divided by the summation of the driving forces. Considering the resisting forces as PR and consider the driving force as PD, we can then calculate the active, the driving force of the resisting forces that are occurring along this diagram. So this is the active earth pressure distribution diagram that we got from the previous slides. We can easily calculate this area, and that will give us the summation of the driving forces. Secondly, we can calculate the weight of the concrete and the soil and the amount of weight coming from the surcharge. And also on the passive side, we can calculate the amount of passive resistance and sum it up over N10 delta prime plus PP, where N equals to W1, W2, W3, W4 times the 10 delta prime plus the passive pressure will give us the summation of the passive resistance or the resisting forces. Now dividing summation of PR over PD, we can easily calculate the factor of safety sliding. On the next part, we also told to find the factor of safety overturning. From the literature, we know the factor of safety overturning is the summation of the resisting moment divided by the summation of the driving moment. Similarly, we can from the active earth pressure side, active earth pressure distribution diagram, we can subdivide it into two parts, and we can calculate PA1, PA2 from the area. Now, if we know the moment arm YA1, YA2 about this point, and if we take the moment, this stands to PA1 times YA1 plus PA2 times YA2. Now, as we know these weights from the previous slides, we can easily get this x1, x2, x3, x4 about this point O, and summation and the PP times the moment arm YP, and get the summation of the resisting moment about point O using this values. Now dividing summation of MR by summation of MD will give us the factor of safety overturning. On the next slide, if we are asked to avoid or discard the value for the passive resistance, then we can simply take out summation plus PP from our diagram and then divide summation of PR over PD. That will give us the factor of safety sliding. On the next one, if we are asked to find the factor of safety overturning without passive, then we can simply discard this moment arm for the passive resistance times the value for the passive earth pressure. Now, for the next part where we have to make comments, we can easily do that based on our results and our techniques of finding the factor of safety. So that's all for question 1. Thank you so much.